For this next problem, we're going to solve an equation in the complex number system. We're asked to solve the equation 3x cubed plus 2x minus 1 equals 8x squared minus 4. We're going to solve that in the complex number system. First thing we'd like to do is move everything to one side and get the right side equal to 0. So we'll have 3x cubed plus 2x minus 1 minus 8x squared plus 4 equals 0. We're going to rewrite this so that the exponents are in decreasing order. We'll have 3x cubed minus 8x squared plus 2x. Then we have a minus 1 plus 4, which gives us plus 3. And that's equal to 0. To solve this equation, if we consider that this left side is a different function called f of x, we're really looking for the zeros of f of x. If we want to list our potential rational zeros, we need to find integer factors of a sub 0, or a constant. That's going to be plus or minus 1, plus or minus 3. We also need integer factors of the leading coefficient, which also will end up being plus or minus 1 and plus or minus 3. So our potential rational zeros, p over q, we get by taking the ratios, and we'll get plus or minus 1/3, plus or minus 1, and plus or minus 3. If we have a rational zero to this equation, it will be one of these listed here. If you graph this function f of x using a graphing utility, it looks like one of our zeros was close to 1, so we might try positive 1 using synthetic division. We list our coefficients for f of x, 3, negative 8, 2, 3. Drop down the 3, multiply and add to get negative 5, multiply and add to get negative 3, we multiply and add to get 0. Now the remainder is 0, which tells us that 1 is a 0 of f of x, which means it's a solution to this equation. Remember that with synthetic division, if the remainder is not 0, then this is not a 0 of the function, which would mean it would not be a solution to our equation. So we have one of the solutions. This is a reduced polynomial, 3x squared minus 5x minus 3, and it allows us to rewrite our function f of x in a factored form. F of x is equal to x minus 1 times 3x squared minus 5x minus 3. All we have to do now is see if we can get any zeros of this quadratic expression here. We've rewritten our function f of x in its factored form. We just want to see if we can factor 3x squared minus 5x minus 3 any further. If we look at it, we see that it is not going to be able to be factored, but we still are interested in finding the zeros of our function. So we're going to set this reduced polynomial, 3x squared minus 5x minus 3, equal to 0, and find any solutions to this equation. This is a quadratic equation, and factoring is not going to help us here. So we're going to use the quadratic formula. A equals 3, b equals negative 5, and c equals negative 3. If we plug these values into the quadratic formula, we'll get x is equal to 5 plus or minus the square root, negative 5 squared, minus 4 times 3 times negative 3. And all of that is going to be over 2 times 3. It gives us 5 plus or minus square root. Now if we work out what we get on the inside, it turns out to be 61. And our denominator here is 6. Since 61 is not a perfect square, there's no way we can reduce this, and there's no perfect square factors of 61, and these are our two remaining zeros. So our zeros for f of x are x equal to 1, x is equal to 5 plus the square root of 61 over 6, and 5 minus the square root of 61 over 6. These are also the solutions to our original equations.